you don't want to just copy it all down. If you haven't done this, you could listen, but you shouldn't be you should then go home and try it yourself. Otherwise, you won't prepare yourself for a test, Unless you've gone through as much as you could, and then you got stuck on something. So, like, we could start with 5B. So that's the one with Chris, Kiona, and Seiko, and Dwayne. Mm-hmm. Okay, they each run 100 meters in a relay race. So when I do these problems, I, read. So in order to do 5B, I've got to do reading. I'm going to have to probably even do 5A. So when I read it, I record. So I'm reading Chris, Kiona, Seiko, and Dwayne each run 100 meters. So I just kind of do little notes. Each run 100 meters. So the reason is there's a lot of writing on this page. And if I don't take little notes, I forget what I read. And then I have to read it over and over again. So I read slow, but then I remember what I've read. Okay, Chris runs his part of the race. And so it tells me how long. So Chris takes 12.35 seconds. And then Kiona, she runs it in 13.12 seconds. And then Seiko, she runs it in 11.91 seconds. It's pretty fast for, if that were middle school, it's pretty fast. For a high school, boy, I would say that's not super fast, but it's not terribly slow either. Middle school, those are pretty fast times. So the team wants to break the school record. So part A, did anybody have a question on part A? So the team wanted to break school record of 48.92 seconds. How fast will Dwayne have to run? Everybody figured that out? Mm-hmm. So what'd you get then so we can record that? So for part A, Dwayne needs to do what?
It was faster than 11.4.
Right. To run faster than 11, what was it? 11.54 seconds. If you ran 11.54 seconds exactly, they would tie the school record. Okay, because the school record was 48 something, right? 48.92 seconds. So part B, the team sets a new record. Okay, so new record. And the new record is 47.65 seconds. So that's the reading for part B. On average, how many meters did the team members run per second? So basically, we want to know their rate per second. And so that would be meters per second, like in a ratio table. Is an easy way to do this, even though you aren't doing it by hand. It helps you catalog your information because they want to know how fast they're running per 1 second. But what we know is that they ran 400 meters altogether, right, in 47.65 seconds. Do you get that? That's what they told us, but we want to know per 1 second. So even though we built the ratio table skill a long time ago with integer numbers, just thinking that way can sometimes make your problem understandable. So you have to divide by 47.65 on the top and the bottom here, because that would give me per 1 second. Do you get that? So the reason I like those ratio tables in the beginning of the year is even when you don't do it by hand and you use a calculator, you can still set it up when you're reading, and it makes your useful information because you have your units there, everything, and then you just pick up your calculator, right? So you just go get the calculator on this one, and you just type in 400 meters divided by the 47.65 and get, ooh,
8.3.
a long number. I don't think that was right.
No, that's what it had for the answer.
Oh, what?
8.3. It was 8.39.
Fast. So that's crazy, because the world record is. Really, that's what it said?
Yeah.
Oh no, you know what it is? I'm misreading it. It's meters per second.
That's what they had for the answer, I think.
Yes, but I misread my own. Look, I was thinking it was 8.3 seconds per 100 meters. Like I lost my focus, but then I looked back at my units. Right, it's 8.3 meters per 1 second. For a minute, I thought it was saying they ran 8.3 seconds for 100 meters, and I was like, no way. Nobody's done that in the whole world. Okay, Julian.
Can you round it up to 8.4 since it's 8.39?
Oh yeah, I didn't get very careful there, did I? I think you would actually go to 8.39 because in track, a lot of times they go to 2 decimals. So your final answer would be, on average. So that doesn't, on average, each person ran about 8.39 meters per second. So that doesn't mean each person ran exactly that. You guys have seen a relay, right? Sometimes, usually the first person and the last person are the fastest two. The slowest person is usually the third leg. And so it's very rare that you would have a relay where they all run exactly the same. Okay? Does that make sense? Okay, Max.
I have a question about number 3 because I'm doing that and I did it with the calculator and I got 30.975 and then on the paper and didn't you say like 35.25 or something?
I'm not sure, but let's finish with the kids that are caught up and then I can help you with that in a minute. I just want to go through that other group first. What other questions? 1 through 7. You guys didn't have any questions? I'm all right. Yeah, Olivia.
Number
C?
for C5.
Same problem, right? Okay, this is great, because what I like is part C says, when I read it, how long did it take, on average, how long did it take each team member to run 100 meters? So I can just draw another line. I don't have to start all over. I just want this to be 100, right? Up here. So what's the easiest way to get to 100? Using the numbers in my table. Yeah, what'd you do, Julian?
Well, I didn't get it right, but you could divide 400 by 4.
Yeah, just go like this, right? Divide by 4. So that means you have to divide this by 4. Do you guys remember the ratio tables? Does it kind of help using that idea? Because it kind of organizes your work. And then you don't have to do a lot of extra writing. You go back to that same table. So you're going to have we know 400 divided by 4 is 100, but we have to divide 47.65 by 4, right? Because that's what's in that column there. So 47.65 divided by 4 is about 11.91, right? We're going to round to 2 decimals. So for part.
That's probably times. The actual times. That's what's take or.
So what does that mean? That if it's one of the actual times, it means the other 3 times add up and divide by 3, you'll get 11.91.
Okay.
So you would say each person runs about 11.91, 100 meters in 11.91 seconds. So do you guys see how I'm phrasing my sentences and I'm sort of pausing and thinking about what I'm saying? That's what I want you guys to do. If you don't write a sentence conclusion, you're not really showing me you know what your numbers mean. Just like you heard me misstate something at first and then I stopped and went, that doesn't seem right. If you write the sentence, you're really closing the deal. So you look at this and you say, it takes each person, you might say on average, right? Because they asked on average, about 11.91 seconds per 100 meters, or to run 100 meters. So you'd say, I should have put on average, right? Because they asked if that was an average. Do you get that? So the sentence piece, I need. On the test, you're going to have to take your numbers and write a sentence that makes sense. Okay? Any other questions on that? So, as far as 8, I'm going to pause this and just read more answers. I guess I'll record this too. So this is the next section, the next type of problem, just using unit rate. So if we look at this problem on page 12, then the people on the string field trip can follow along. The Madison Middle School Outdoor Club went on a 3-day hiking trip, like a backpacking trip in a national park, like up in Rocky Mountain. How many people have been backpacking? It's pretty good. So, backpacking, if you haven't done that, usually, you go in a wilderness area. It's not really the same as camping because you can't drive there. You put a backpack on, you carry everything you need, and then you hike into a lake or something and camp. And then you get up the next morning and maybe hike to another place. And then you do that, and then you come out at some other wilderness area, or you go back to where you started. It's a little different than car camping. So the club members made a table to show the distance traveled and the time spent hiking for each of the 3 days. Okay? And how can you use the data above to compare the walking rates for each of the 3 days? So how could we say, like, when they went the fastest or the slowest? What do you guys think? What do you think, Julian?
The biggest distance and the least amount of time.
So how are you going to convince somebody?
Or I have to go,
Olivia?
you have to go by.
You could? Max?
Or I guess I had an idea and it didn't work.
Okay, somebody new. Come on, you guys. What did we just do on the last problem?
Ratio table.
If we used a ratio table, what could we find?
The unit rate.
The unit rate. Which means like what, Alora?
The distance
The distance traveled in an hour. If we could figure out how much they traveled per hour each day, we could tell which is fastest. Does that make sense? What we'd have to do, this is kind of like a ratio table here, but we'd probably want to do 3. A little ratio table for day 1, one for day 2. In other words, we might just want to pull the table apart. So if we did like day 1, you have miles per hour. So a ratio table is just helping organize work. So we know we did 9 miles in 4 hours. So if I wanted to figure out the rate, like Alora said, for 1 hour, what do I have to divide by? Yeah, Max.
you could divide by,
Want to get from here to there.
well, that would be 4.
Divide by 4, right? And so to divide by 4, you could pick up a calculator. You guys can do this also in your head, because 4 goes into 9 how many times? 2, and the remainder is,
1.
so 2 and a 4, which is the same as 2.25. Right, so in this unit, I said you guys could use a calculator. So you could also do that, right? You could say, well, 9 divided by 4 is 2.25, but it's good to practice, okay? So that tells us what, Andrew, on that, about day 1, what can we say?
It took 2 hours and 25 minutes to hike.
Yeah,
Yeah.
no, you got look at your units in the table.
Oh, it took 2 miles and 25. No, it took 1 hour.
There you go.
And to hike 2 hours.
So it took 1 hour to hike 2 miles and 2.25 miles. So even though I think you guys know, if I'm asking you to write a sentence, I'm asking for a higher level skill, right? So day 1, they hiked 2.25 miles per 1 hour. That's the unit rate. Okay? So day 2. New table. Just to keep things easy to read. Miles and hours. So, Joanna, what am I going to put here for day 2? On the top. 12 miles in 5 hours. So again, we want to do division. What do we divide by, Joanna? We're going to get to 1 hour. I divide by 5.
I know what you get.
What do you get?
2.4.
2.4. 5 goes into 12 twice, right? The remainder is, it's 2, and the remainder is 2/5, right? 5 goes in 12 twice. That's 10, right? Remainder 2. So we say 2 out of 5 left. Or if you type it into the calculator, you're going to get 2.4, right? So, Emma, what's the sentence that would go with this?
So it takes 1 hour to hike 2.5.
Right. So day 2, they hiked 2.4 miles. Good job. And is it exactly every 2.4 miles is an hour?
No.
It's the average. It means overall, right? If it's uphill, they might go a little slower. If it's downhill, they may go a little faster, right? But the average rate, so it's an average rate. Okay, so Ryan, how about the third ratio table? What's that going to look like? Miles per hour.
12 and 6. No, 12 and 6.4 and 2.5.
Good. So day 3, miles per hour. It's 6.4 miles
2.5.
and 2.5 hours. So Ryan,
Yeah.
how do I figure out to get to 1?
4
By 2? So 2.5 divided by what?
Point.
Yes. Divided by 2.5. Oh, not letting me put decimals in. Okay, so 6.4 divided by 2.5. So did you type it in?
Yeah.
What'd you get, Max?
I got 2.56.
Somebody want to double check? Just because I don't have a calculator? Well, I do, but.
Well, I have a calculator.
Right, it's always good to double check though, right? You should do it twice when you have a calculator. I mean, I can do it too, but it's good for you guys to double check its work. So, we're checking,
2.56.
okay. 6.4 divided by 2.5. He's right. So what's the sentence that goes with it, Max?
They hike, they hike 1 mile every 2 hours and 50 seconds.
Look at the table again.
They hike 2.56 miles every 1 hour.
Yeah, that's their rate, right? Miles per hour. So they're averages, right? So when I look at this, the fastest is what? Think about that, yeah, Julian?
Day 3. Oh yeah, I was.
Why is it day 3? Yeah,
Because they hike the most
because
distance.
they went the most distance in the same time. You guys, originally when you said, Max, this one, 2.25, you looked at the smallest number, right? but that means they did the smallest distance in the
Yeah,
same amount of time.
and-
It's a very easy mistake to make, especially if you rush. Okay, so you can do problems like that with ratio tables, so go to problem 24 and try it, and we'll talk about it. And so problem 24 is on page 17. So in that problem 24, what is it about the driving, right? They drive 500 miles in 10 hours. That's their plan, right? It's like maybe driving from here to, I don't know, New Mexico. It's a long drive. So maybe, you would figure out how long, say you want to get to New Mexico in 8 hours, you would look and see how far away New Mexico is, like Taos. And then if you want to get there in 8 hours, you would divide and then see if you could do that without breaking the law, right? So here, they want to go 500 miles in 10 hours, and they want to see what kind of speed they would have to drive to do that. So we want to figure out what their rate is per 1 hour. So I have to divide by what? 10, right? Divide by 10. And when you divide by 10, you get 50. And so even though you guys can do that in your head, the advantage of the ratio table in this problem is that's just part A, right? So part A asks what their rate would have to be, and you would say they would have to go at 50 miles per hour for part A, right? But Aurora, read me part B.
At the rate from part A, how far would the Andersons travel if they drove for 8 hours?
So at that rate, how far would they have to travel? So Mark, how would you add to this table to get 8 hours in here? Yeah, you would multiply by 8, exactly, right? So then you would have to do that here. So somebody said they had a number that didn't make sense. When you set it up in the ratio table, what's 8 times 5? 40, right? So 8 times 50 is. So that means they're going to go 400 miles in 8 hours. Do you get that? You could get 12 hours just by multiplying by 12, right? And then everything's in your ratio table. It's all right there. So what's 12 times 5? 60. So 12 times 50 is 600. So for part B, they can do 400 miles in 8 hours and 600 miles in 12 hours. So tonight, you guys, before you pack up, I really strongly recommend putting your information at a table like that. You guys can go with the crutches because it helps you minimize your work and it's really organized. And then you could just keep adding to the same table to do some different parts of the problem. Does that make sense? Good?
Yeah, I'm looking at that.
Okay.